In this video, we'll do another worked example from a Trig Graphs question paper. And so the first thing that they ask us is to work out A and B. And so the safe way you can always do it is you can say, oh, I'm missing one letter, so I can sub in 1 point, and you can look for one exact point on the graph, and you could do that for finding B as well. If you want to think about it, what's happening, A is just the amplitude, and so a normal sine graph should look like that. This graph, instead of going up first, is going down first, and it should go to 1, and this goes to -1. So it's basically a graph that's going the wrong way, but everything else about it is normal. So that means that A would just be -1, and then B affects the period. And so I'm going to be looking to see, does this tan graph happen more or less often than normal? The first asymptote should have been at 90, but now it's happening at 45, so it's happening twice as often. So B would be 2. You can also really importantly look at the mark allocation. So this is only for 2 marks, so it's probably 1 mark for A, 1 mark for B. If it was for 4, then maybe you're wanting to do a whole bunch of working out and subbing in. So let the mark allocation guide you. What is the period of f of 3x? So what I find helpful for these is look at f, and it's just a normal sine graph that's gone the wrong way. And so a normal sine's period would just be 360. So it helps to always work out the normal. And then the 3x just means I divide it by the coefficient of x. So I divide it by 3, and just like that, I've got the period of that graph. The last question is determine the values of x in the interval 90 to 225. Okay, so I'm only looking from here to there, even though there might be other answers relevant before this, for which fx times gx is less than -1. A lot of people freak out with these kind of questions. Hopefully I've got a technique that makes it easier for you, which I will cover in another video on functions. But for now, fx times gx, I'm literally asking myself, is this where the graphs are in the same place or different? In this case, they're in different places. Why? Because if the signs were different, so if that was a minus and that was a minus times a plus is a negative, which is less than 0, or vice versa. Whereas, just a quick tangent, no pun intended, if you've got that times that is bigger than 0, then how would you look on a graph to answer it? You'd be looking where the graphs are in the same place, because they would both be positive to get bigger than 0, or they would both be negative. And by same or different, I mean let's go back to this one. Different would mean the one graph is above the x-axis and the other one is below. Then I would say they're in different places. Whereas for this whole region here, I would say the graphs are in the same place because they're both below this line. So where are they in different places? So from 90, as it begins, the graphs are in different places. This guy's above the line, this guy's below. So it's from 90, they're in different places up until 135, but I don't put a or equal to because there's an asymptote there. Then straight after 135, they're both below this line, so they're in the same place. And then after 180, they're in the same place again. They're both above. So the only place they're different is that, but the question said or equal to, and at 180, they are equal to 0. Exactly. And so my answer, instead of being an inequality, will be just, it's there. I hope that was helpful just as a discussion around graphs being in the same and different place, as well as some of the other things we learned in this video. If you found this helpful, please like this video, subscribe to our channel, and share it with your friends. Thanks.